Netflix is huge. We get it. We watch it all the time.
This is a vacation.
Hold it right there.
Hey everyone, my name is Michael and I'm the founder of SlashDev.io, a platform for connecting the best software engineers from around the world to fast-growing companies. And today I'm going to talk to you about Netflix's software architecture. And try to explain to you how they support over 231 million paid subscribers and stream to users in over 190 countries around the world. So Netflix is huge. We get it. We watch it all the time. In 2022, Netflix had over $30 billion in revenue and streams about 141 million hours of content every single day. So we're talking about a massive amount of content that, 15, 20 years ago was not possible at all to stream over the internet. So how is Netflix getting this done? So Netflix's software architecture is broken into three main areas. You have the client devices like your computer, your tablet, your Apple TV. You have their actual backend services and APIs, which handle all the logic. And then you have their content delivery network that handles actually getting these massive video files to all of its users around the world. So first of all, you have the client devices. Pretty simple, but you have their local software running on all of these different devices. So this can be gaming consoles, phones, tablets, computers, browsers, etc. And this is the actual device where the clients are interacting with Netflix. And so they have to support different devices, different operating systems, and make sure as many people as possible can use Netflix. So the first thing that happens when a client device interacts with Netflix's backend software is you run into Amazon's Elastic Load Balancer. This is a very common tool that's used with any large system where you have multiple servers deployed and you need to manage the load. And you can think of this kind of like a traffic cop that makes sure that your request to stream a certain movie is going somewhere where it's going to get fulfilled and you're not going to have to wait in line. From this, you're mapped to the Zuul API gateway. This is a API gateway by Netflix that kind of encompasses its three main services that its backend handles. So the three main services, first you have the signup API. This handles all things related to signing up, trials, billing, etc. Next, you have the Discover API, which helps populate recommendations, different categories, and really give you all the custom machine learning generated suggestions. Even the thumbnails are actually custom generated for you. And so the Discover API helps to grab this type of data and serve it to you. And then, of course, most importantly, the Play API. And the Play API handles everything related to playing and streaming titles, as you can imagine. Netflix has famously been an early adopter of the microservice architecture, and there's actually a great deep dive on the early days of this by Josh Evans on YouTube if you want to check it out. Highly recommend it. Really interesting just to see how one of the technical leaders at Netflix thinks about microservices and why they had to use this to support the type of problems they're trying to solve. But essentially, to break this down for you, microservices break down actions into their own small programs so that if one breaks, you can easily queue up another program to handle that same job of signing you up for a trial or streaming a service. And when you have a system as large as Netflix, this is incredibly important to make sure that you have as little downtime as possible. So let's talk about the real magic of Netflix's software architecture. The real problem that they have to solve is getting this huge volume of video files streaming on all these devices. Now, there's a common tool that websites use in order to get content to users faster, and that's called a CDN, or Content Delivery Network. You can think of that as servers located in locations all over the world where you can store the same data close to the end user. so that when they want to watch that episode of Vikings or that new episode of whatever show you're watching, they can stream it right away. So this fundamental ability to stream 140 million hours of content every day is rested firmly on the shoulders of the CDN. But in Netflix's case, traditional CDNs were not enough. And so what they had to do was actually build their own system. So Netflix has built their own system called OpenConnect, which helps them to handle this. And what do I mean by built their own system? Did they write their own code? No, they actually have physical devices that store and distribute these files to end users. So let me give you a little bit of background on how this works. So a really simple overview here again, but we have the client devices which send requests to the backend system of Netflix, which then says, hey, I want to play this title. That does all the logic of which server, which location to send this request. And then eventually that gets in communication with an OpenConnect device, which then streams that to the end user. The internet rests on the shoulders of ISPs, or internet service providers. These are companies like Verizon, etc., all over the world who have servers that allow you to connect and purchase your access to the internet. That's how you can search things, that's how you can download files, that's how you're watching this video right now. Your traffic is being routed to an ISP who then handles routing that to the correct service that you're consuming. And so in Netflix's case, they've built actual physical devices that store all of their files and get placed in racks in the server rooms of these ISPs. And they've been fairly secretive about this process, but I managed to dig up a user on Reddit who actually was able to acquire one of these old depreciated devices and take a look. So let's give it a peek. All right, so let's take a look at what we have here. So this is the OpenConnect device that was actually acquired by a Reddit user who worked for one of these ISPs. You can see there, Netflix OpenConnect appliance. And basically when he opened this thing up, it had a processor, had 64 gigabytes of DDR3 memory, 10 gigabyte Ethernet card, about 36 7.2 terabyte drives, and 6 500 gigabyte Micron solid state drives. So what that means is essentially 262 terabytes of storage, the ability to interface and send these files easily, and a little bit of processing power to handle that. We also were able to find a quote from one of the team at OpenConnect who kind of explained the device. So the quote is, they're designed to have a huge pipeline from disk to NIC and not do much else. The CPU is just enough to support that mission. It has a custom NIC, but it's not actually anything crazy. NIC is a network interface controller, basically controls the flow of information to the internet from the device. And so, yeah, I mean, this is definitely one of their devices. We can see here on the OpenConnect website, this is kind of what they look like in the server room. So this is the magic of what makes Netflix run. It's these OpenConnect devices that make it so when you click on a title, it streams right away. And they have these in servers all over the world. Their website actually walks you through how to get approved as a vendor and put these into your server rooms if you're an ISP. Gives you all the details of what you need at your server location, etc. And so, yeah, this is actually physically what makes Netflix do what it does. All right, awesome. So we got to the bottom of it. We found the actual device, and you got a quick overview of Netflix's architecture. Now, this is a very surface level overview. There's minute detail depending on each microservice framework they're using, how they're monitoring their servers, the different programming languages that they use within their systems, all of the different functions and operations that they're using. So There's a lot more here. That's why they need engineers all over the world, some of the best engineers in the world, helping to support them to build this system. But I hope that this gave you a little bit of a peek behind the curtain of how Netflix works. And maybe this will inspire you if you're thinking about building your own content website or Netflix competitor. Gives you a bit of ideas on the core fundamental building blocks you need to put together to do this. And again, I only touched on a small part of Netflix's architecture, so there's obviously much more going on here than what I touched on. So, if you're curious, if you're a back-end engineer yourself, make sure you dive into different aspects of this and get up to speed with how they're handling things, the different types of databases they're using to store information, the different types of tools and frameworks they're using to orchestrate these microservices, and continue to learn and master your own skill set. Thank you for your time. Make sure you like and subscribe if you enjoyed this, and keep building. Cheers.